Dawn breaks over a Pacific island in the summer of 1944. The air is heavy with salt and smoke. Coral dust hangs low, stirred by shellfire that has not yet stopped. Palm trees are splintered. The ground trembles with distant naval guns. Along the shoreline, Japanese bunkers still fire in short, deliberate bursts. Concrete positions, carefully measured and reinforced, stare outward toward the sea. These defenses were designed to endure, to deny landings, to bleed attackers until nothing remained. Then something unexpected appears behind the first wave of American infantry. Bulldozers. Not weeks later, not after the fighting ends, but now while artillery still falls, while snipers remain hidden in the ridgelines. Steel blades bite into shattered coral as U.S. Navy construction battalions move inland, unarmed or lightly armed, pushing machines forward where logic says no one should stand. Runways are marked on ground that was rubble minutes before. Roads are scraped into existence under fire. Fuel dumps rise beside foxholes. For Japanese engineers watching from concealed positions, the scene defies every assumption they held about war. Their defenses were meant to stop armies, but this enemy does not wait to win before it builds. And, with each hour that passes, the island itself begins to change, reshaped into a weapon aimed back at Japan. From this moment, the story turns to how two very different engineering philosophies collided in the Pacific. Long before the first American bulldozer touched coral sand, Japan had already turned the islands of the Pacific into carefully calculated strongholds. Imperial Japanese military planners did not see islands as temporary positions. They saw them as walls, fixed barriers meant to absorb shock, delay advance, and exact maximum cost from any attacker who dared approach the home islands. Every atoll, volcanic ridge, and jungle-covered slope was studied not for flexibility, but for endurance. Japanese engineers were trained within a doctrine shaped by limited industrial capacity and a belief in decisive defense. Concrete, tunnels, and camouflage positions mattered more than speed or replacement. Once built, a position was expected to hold often until annihilation. Withdrawal was rarely considered. Reconstruction under fire was not part of the equation. By the late 1930s, this philosophy was already visible across the Pacific. Airfields were carved carefully, often by hand. Roads followed terrain rather than reshaping it. Defensive works blended into natural contours. Caves were expanded into underground fortresses. Artillery was hidden behind thick concrete or inside hillsides. Supply depots were buried deep, unreachable from the air. This approach reflected both necessity and belief. Japan lacked the raw materials of the United States. Steel, fuel, heavy machinery, and transport capacity were finite. Engineers compensated by building strong positions once, carefully, deliberately, then defending them with discipline and sacrifice. In early campaigns, this system appeared effective. On islands captured in 1941 and early 1942, Japanese forces worked methodically. Airstrips were constructed to exact specifications. Defensive belts were layered outward from command centers. Every bunker had overlapping fields of fire. Beaches were mined and pre-sighted. In many places, attackers would have to cross open ground under direct observation. Japanese planners assumed time favored the defender. They believed any attacker would need weeks, sometimes months, to neutralize defenses before using captured terrain effectively. Airfields, once damaged, would require long repairs. Ports destroyed by bombardment would remain unusable. Infrastructure loss was assumed to paralyze operations. Underlying this belief was experience. Japanese engineering units had rebuilt slowly. In China, where resources were scarce and heavy machinery limited, combat engineers were expected to fight as infantry when needed, not to rebuild while shells were still falling. Construction followed combat. Never the reverse. There was also a cultural element. Japanese military doctrine emphasized preparation and resolve. A position built perfectly once should not need rebuilding. If it fell, the failure was not engineering, it was circumstance or sacrifice. Flexibility was not prioritized. Endurance was taught by 1943. As American forces began advancing across the Pacific, Japanese island commanders doubled down on this thinking. On places like Tarawa, Saipan, and Iwo Jima, defenses became deeper and more complex. Airfields were protected by anti-aircraft, guns, and underground shelters. Engineers focused on denying terrain, not enabling its reuse. What they did not anticipate was an enemy that treated destruction as a temporary inconvenience. American planning did not view islands as fortresses to be captured intact. They were stepping stones, platforms to be reshaped rapidly, even violently, into forward operating bases. The Japanese expected engineers to wait for silence before working. Instead, they would soon watch men build while the ground was still exploding. That assumption, quietly held and rarely questioned, would begin to collapse the moment American forces landed with machines instead of patience. And behind those machines stood a new kind of military unit, created specifically to turn chaos into infrastructure. The United States entered the Pacific War with an advantage Japan never fully grasped, not simply industrial capacity, but a radically different philosophy of how war could be sustained. American planners understood that distance would define the conflict. The Pacific was not a single battlefield. It was thousands of miles of ocean separating shipyards, factories, and training grounds from contested islands barely large enough to appear on maps. Victory would depend not just on defeating enemy forces, but on building functioning bases faster than the enemy could destroy them. This realization produced an unusual solution. In early 1942, after the attack on Pearl Harbor, the U.S. Navy quietly approved the creation of a new force, the Naval Construction Battalions. They would soon become known by a shortened name drawn from their initials, Seabees. Their mission was unprecedented. They were not traditional combat engineers tasked with demolitions or bridge repair after battles. They were skilled civilian tradesmen, carpenters, electricians, heavy equipment operators, steel workers trained to build entire bases in active combat zones. Their official motto reflected this shift in thinking: Construimus, Bacuimus, we build, we fight. Unlike Japanese engineers, Seabees were organized around speed, redundancy, and improvisation. They trained to operate heavy machinery under fire. They learned how to unload equipment without ports, how to create roads out of coral, how to repair bomb-damaged runways overnight. Construction was not delayed until security was complete. It happened alongside it. This doctrine emerged from American industrial logic. If something was destroyed, it could be rebuilt quickly. If a runway was cratered, steel matting could be laid over it. If a port was shattered, pontoon piers could replace it. If terrain resisted shaping, machinery would force it to comply. The Seabees were equipped accordingly. Bulldozers, graders, cranes, dump trucks, and compressors were standard issue. Prefabricated materials were shipped in bulk. Equipment losses were expected and planned for. Unlike Japanese engineers who conserved resources, Seabees consumed them to save time. Training emphasized adaptability over permanence. Seabees learned to work with incomplete plans, shifting objectives, and damaged supplies. Officers were encouraged to make immediate decisions rather than wait for orders. Speed mattered more than perfection. By mid-1942, the Seabees had already proven their value. On Guadalcanal, they helped keep Henderson Field operational under constant Japanese bombardment. Runways were repaired by hand and machine between air raids. Bomb craters were filled while aircraft circled overhead, waiting to land. The lesson was immediate and unmistakable. Air power followed construction speed. American commanders took notice. Wherever Marines or Army units landed, Seabees followed closely behind. Sometimes they landed within hours. Their presence meant that even heavily damaged islands could be turned into functional bases almost immediately. Air superiority could be established faster than Japanese planners believed possible. This was not merely logistical efficiency. It was psychological warfare. Japanese commanders expected airfields to remain unusable after bombardment. They believed ports would be neutralized for extended periods. Instead, they watched American aircraft operating from runways that had been destroyed days earlier. They saw fuel depots reappear where explosions had erased them. The Japanese defense doctrine assumed time favored the defender. The Seabees reversed that equation. Time now favored the builder. By late 1943, as American forces prepared to strike deeper into the Central Pacific, this build under fire philosophy had become central to Allied strategy. Islands would no longer be neutralized and bypassed slowly. They would be seized, rebuilt, and used immediately, often before the fighting had fully ended. For Japanese engineers observing from hidden positions, the realization was unsettling. The enemy did not wait for victory to construct. Construction was the victory. And soon, on islands where defenses had been calculated to last months, the Seabees would arrive to prove just how quickly assumptions could collapse. What followed was not simply a clash of armies, but a confrontation between two ways of understanding war itself. The first thing many infantrymen noticed about the Seabees was not their equipment, but their posture. They did not move like soldiers advancing toward an objective. They moved like men arriving for work. Helmets sat loose. Sleeves were rolled when possible. Cigarettes burned between tasks. Yet they stepped forward under the same fire as the Marines beside them, operating machines that made them impossible to miss. For the Seabees themselves, the work was personal. Many had left civilian jobs only months earlier. They were older than most combat troops, carpenters from the Midwest, dock workers from the coasts, heavy equipment operators who understood machines better than rifles. They had not trained for glory. They trained to finish jobs. On islands like Tarawa and Saipan, Seabees began clearing ground before the last shots faded. Wreckage was pushed aside without ceremony. Japanese obstacles were dismantled methodically. Where coral resisted excavation, explosives were used to break it down, not for combat, but for grading. From a tactical standpoint, this speed changed everything. American forces no longer needed to wait for rear area engineers to arrive. Runways were operational within days, sometimes hours. On Saipan, airfields damaged during the invasion were repaired quickly enough to support fighter operations while ground fighting still continued inland. This had immediate battlefield consequences. Fighters provided close air support from newly repaired strips. Transport aircraft brought supplies directly to contested areas. Evacuation of wounded accelerated. The tempo of operations increased beyond Japanese expectations. Japanese commanders watched this unfold with disbelief. Their planning assumed that American forces would need time to regroup after heavy fighting. They expected logistical pauses. Instead, each pause was filled with construction reports from Japanese units described frustration. Bombardment that should have delayed operations instead seemed to trigger rebuilding. Airfields reappeared almost as soon as they were targeted. Roads cut through terrain once considered impassable. The enemy's reaction was not disbelief alone, it was confusion. Japanese engineers had built their defenses with care and precision. Yet those defenses were static. When damaged, they stayed damaged. Repairs required time, materials, and safety. The Americans seemed to ignore all three requirements. From the Japanese perspective, the battlefield itself appeared to betray them. Terrain they had shaped over months was reshaped in days. Carefully concealed positions were exposed by earth-moving equipment. Natural cover disappeared under steel blades. There was also a human disconnect. Japanese doctrine emphasized concealment and patience. The Seabees worked openly, loudly. Machines roared. Dust clouds rose. For defenders trained to punish movement, this behavior seemed irrational, yet punishment failed to stop it. Shelling slowed construction but rarely halted it. When equipment was destroyed, replacements arrived. When men were wounded, others stepped in. Work resumed quickly, sometimes within minutes. This relentless continuation created a tactical pressure no weapon alone could match. Japanese units faced an enemy that refused to pause. Even when American forces took casualties, infrastructure kept advancing. The island was being transformed regardless of resistance. For Japanese soldiers, the realization was deeply unsettling. They were defending positions designed to deny use. The Americans were converting those same positions into assets. Each rebuilt runway meant more aircraft overhead. Each road meant faster troop movement. Each fuel dump meant sustained operations. What had been planned as a fortress became a platform dot. By the time Japanese defenders adjusted, the damage was already done. Their defenses were no longer denying space. They were enabling the enemy. The Seabees did not win battles alone, but they erased the advantage of delay. They collapsed the timeline Japanese planners relied upon. And as this pattern repeated across island after island, another realization began to form, one tied not just to labor or machinery, but to leadership and technology working in quiet. Coordination. That deeper system, largely invisible from the trenches, would soon reveal why American construction could not be stopped. Behind every bulldozer pushing coral and every runway rising from rubble stood a system far larger than the men operating the machines. The technological advantage was not subtle. The United States entered the Pacific War with access to heavy equipment. Japan simply did not possess in comparable numbers. Bulldozers, graders, cranes, compressors, and dump trucks were mass-produced, standardized, and shipped forward in volume. When one machine was destroyed, another followed. When spare parts were needed, they were already en route. One innovation proved especially decisive: prefabricated solutions. Steel matting, later known as Marston matting, allowed Seabees to create usable runways over unstable ground in days. Pontoon causeways and floating piers replaced shattered docks. Portable power systems brought electricity to islands that had never supported it before. These were not improvised miracles. They were planned outcomes of industrial foresight. Leadership ensured these tools were used without hesitation. American naval and marine commanders gave Seabees unusual autonomy. Construction officers were empowered to make immediate decisions based on battlefield realities. Waiting for formal clearance was discouraged. If an airfield could be built, it was built. If a road shortened supply lines, it was carved out. This command philosophy contrasted sharply with Japanese rigidity. Japanese engineers operated within strict hierarchies. Deviating from plans required approval. Resources were conserved carefully. Equipment losses were unacceptable. The Americans accepted loss as a cost of speed. Coordination amplified this advantage. Seabees worked alongside Marines, Army units, and naval forces in near-continuous synchronization. Naval gunfire suppressed threats while construction advanced. Aircraft provided cover from freshly repaired strips. Logistics followed infrastructure immediately. This created a feedback loop. Construction enabled air power. Air power protected construction. Each reinforced the other. Japanese observers struggled to counter this cycle. Bombing airfields no longer achieved lasting results. Destroying ports delayed nothing. The very act of attacking infrastructure seemed to accelerate its replacement. There was also a moral dimension that went beyond efficiency. For American forces, the Seabees embodied a belief that war could be shaped, not merely endured. Their work suggested inevitability. No matter how hard the enemy fought, the machinery would return, the runway would be repaired, the road would reappear, the base would function. This belief affected morale. Infantry units fought knowing supplies would arrive. Pilots flew knowing airfields would be ready. Wounded soldiers trusted evacuation routes would exist. Construction created confidence. For Japanese defenders, the effect was corrosive. Their sacrifices did not produce lasting denial. Damage inflicted did not hold. The landscape itself seemed to favor the attacker. Reports describe a growing sense of futility as American operations resumed with relentless regularity. Leadership on the Japanese side recognized the problem, but lacked solutions. Without comparable machinery, fuel, or industrial depth, they could not match the pace. Their doctrine did not allow for rapid reconstruction under fire. Their assumptions no longer held. By late 1944, Japanese commanders increasingly relied on depth and concealment rather than infrastructure denial. But even these adaptations failed to stop the transformation of islands into American strongholds. What emerged was a stark contrast. One side built once and defended until destruction. The other rebuilt endlessly, faster each time. The Seabees did not seek glory. Their victories were measured in hours saved and runways completed. Yet their impact reached far beyond engineering. They changed the nature of the battlefield itself. And when American forces reached the most heavily defended islands of the Pacific, this system tested, refined, and accelerated would face its greatest trial. The moment when speed, steel, and fire collided would define the turning point of the Island War. By late 1943, the Pacific War had reached a phase where Japanese defenses were no longer improvised or thinly spread. They were deliberate, deep, designed to resist overwhelming force. And on several islands, Japanese engineers believed they had finally created positions that could not be quickly undone. Tarawa was one of the first tests. The atoll was small, heavily fortified, and brutally defended. Japanese engineers had reinforced bunkers with concrete and steel. Airfield damage was expected to be decisive. Bombardment from sea and air reduced much of the island to debris. By doctrine, this destruction should have rendered the airstrip unusable for weeks. Seabees began working almost immediately. Under sporadic fire, they cleared wreckage, filled craters, and laid steel matting over damaged sections. Within days, aircraft were landing. The island, declared secured only after immense cost, was already functioning as a forward base. Japanese expectations of delay collapsed. Saipan followed in 1944. Here, Japanese defenses were more extensive. The island's size allowed depth, and its airfields were critical to American plans. Japanese engineers had carefully placed anti-aircraft guns, protected runways, and prepared demolition plans. Yet once again, destruction did not achieve denial. Seabees landed alongside combat units. While infantry fought inland, construction crews repaired a Slido airfield. Bomb craters were filled with coral and crushed rock. Matting extended usable surfaces. Aircraft arrived sooner than anticipated, providing immediate support and extending American reach. The pace shocked Japanese command. Airfields they believed neutralized were operational while fighting still raged. The psychological impact was severe. Saipan's fall brought American bombers within range of Japan itself, a consequence accelerated by construction speed. Then came Iwo Jima. This island represented the extreme of Japanese defensive engineering. Volcanic rock resisted excavation. Tunnels honeycombed Mount Suribachi. Airfields were cratered repeatedly by naval bombardment. Japanese planners expected reconstruction to be slow, even impossible. The Seabees proved otherwise, despite the terrain and constant shelling. They repaired runways under fire. Volcanic ash complicated compaction. Machinery sank. Adjustments were made in real time. Crushed rock was imported. Matting was reinforced. Within days, damaged strips supported emergency landings for damaged bombers returning from Japan. Each landing saved lives. Each repair undermined Japanese strategy. Okinawa amplified the pattern. This was the largest amphibious assault in the Pacific. Japanese defenses were layered and deep. Infrastructure was expected to remain unusable for extended periods. Instead, Seabees expanded ports, built roads, and repaired airfields at unprecedented scale. Supply flowed. Aircraft surged. The island became a massive staging ground. From the Japanese perspective, the turning point was unmistakable. Their defenses were no longer delaying the inevitable. They were accelerating American momentum. Every island captured became stronger than the last. What had been envisioned as barriers became stepping stones. Japanese engineers reported the same phenomenon repeatedly. Bombardment no longer achieved lasting effect. Destruction did not equal denial. The Americans rebuilt faster than positions could be neutralized. This was not simply a matter of numbers. It was doctrine made visible. Speed replaced patience. Adaptation replaced permanence. And as the Americans pushed closer to Japan, the realization set in that no island, no matter how carefully engineered, could remain unusable long enough to matter. Yet the full weight of this realization would only be felt when its consequences reached Japanese skies and cities. That moment, when rebuilt runways turned into launch pads for sustained air operations, marked the true point of no return. The decisive shift did not announce itself with a single explosion or surrender. It arrived quietly, carried on the sound of engines lifting off from runways that should not have existed. By mid-1944, the Pacific War had entered a new phase. American forces were no longer fighting simply to take islands. They were using those islands almost immediately as operational engines. The transformation was subtle in its beginnings, but devastating in its effect. On Saipan and Tinian, Seabees expanded airfields at a pace that stunned observers. What had been damaged strips became long, reinforced runways capable of handling heavy bombers. Fuel storage appeared in volume. Maintenance areas followed. Command facilities rose where jungle and rubble had stood weeks earlier. These were not temporary installations. They were permanent enough to support sustained operations. Japanese planners had believed that even if islands fell, infrastructure damage would delay strategic use. That assumption now collapsed completely. The Seabees had removed the delay from warfare. By late 1944, B-29 Superfortress bombers began operating from the Marianas. This development marked a psychological rupture. For the first time, American aircraft could strike Japan regularly, not as isolated raids, but as organized campaigns. These operations were possible only because airfields had been built, repaired, and expanded under combat conditions. Japanese engineers understood the implications immediately. Every repaired runway represented not just local defeat, but strategic exposure. Each island base multiplied American reach. Destroying infrastructure no longer prevented its use. It merely triggered reconstruction. Efforts to counter this cycle failed. Japanese air attacks damaged facilities temporarily. Artillery fire cratered surfaces repeatedly. Yet the Seabees responded with routine efficiency. Repairs became standardized. Work continued in shifts. Damage was measured in hours, not weeks. The enemy's reaction shifted from disbelief to resignation. Intelligence assessments noted that American bases returned to operation faster after each attack. The scale of reconstruction grew rather than shrank. Infrastructure density increased. Roads widened. Ports deepened. Airfield capacity expanded beyond pre-invasion levels. This was a turning point in practice, not theory. From these rebuilt islands, American air and naval power began operating continuously. Supply chains shortened. Aircraft turnaround times improved. Damaged bombers landed safely instead of ditching at sea. Crews survived because runways were ready. The Seabees had converted geography into advantage. On Iwo Jima, this effect was immediate and measurable. Emergency landings for damaged B-29s saved thousands of aircrew lives over the course of the campaign. Japanese planners had never anticipated that even heavily contested islands could function in this role so quickly. Okinawa extended the pattern to its limit. The island became a massive logistics and air hub, supporting operations at a scale Japan could not match or disrupt. Despite intense resistance, infrastructure expanded relentlessly. The cumulative effect was overwhelming. Japanese defenses were no longer slowing American advance. They were being absorbed into a system that converted destruction into progress. Every battle ended not with exhaustion, but with expansion. By the time Japanese leadership recognized the full scope of the problem, it was irreversible. The industrial momentum behind American construction had reached critical mass. The Seabees were no longer exceptional. They were expected. Their work had become routine. The war's geography had been rewritten. Islands once meant to stop. The enemy had become the means by which the enemy closed in. The Pacific, vast and protective, had been bridged by steel, coral, and concrete. And as pressure on Japan intensified, the consequences of this transformation would ripple far beyond the islands themselves, reshaping strategy, morale, and the outcome of the war. Those consequences, measured in shifts of power and perspective, would define the aftermath of the Seabees' unseen victories. When the fighting on each island finally subsided, the most important changes were not always visible in the wreckage. They were visible in the maps that followed. American planners no longer marked captured islands as rear areas or temporary footholds. They marked them as hubs, nodes in a rapidly expanding network that stretched across the Pacific. Each rebuilt runway, port, and road shortened distances that had once defined the war. The numbers tell part of the story. By the end of the war, U.S. Navy Seabees had constructed or repaired hundreds of airfields across the Pacific. They built thousands of miles of roads. Millions of square feet of runway surface were laid, often under combat conditions. Ports capable of unloading entire fleets were created, where none had existed before. More important than scale was timing. Airfields that Japanese planners expected to remain unusable for weeks were operational in days, sometimes in hours. This acceleration compressed campaign timelines. Operations that would have required pauses instead flowed continuously. American forces maintained pressure without giving defenders time to recover. Operationally, this changed how battles were fought. Supplies arrived closer to the front. Aircraft flew more sorties with shorter turnaround times. Medical evacuation improved dramatically. Survival rates increased not because combat was less intense, but because infrastructure supported endurance. Japanese efforts to disrupt this system proved ineffective. Bombing campaigns inflicted damage but failed to create lasting denial. Artillery fire delayed work but did not stop it. Even suicide attacks on ports and ships could not dismantle the underlying capacity to rebuild. Strategic consequences followed. With secure bases established rapidly, American forces gained flexibility. They could bypass heavily defended islands knowing they could build alternatives nearby. They could concentrate power where needed without fear of logistical collapse. The Japanese defense perimeter, once carefully constructed, became porous. Psychologically, this eroded Japanese confidence in defensive planning. Reports from late-war assessments acknowledged the inability to neutralize American bases for meaningful periods. The assumption that destruction equaled delay was proven false. For American leadership, the lesson was clear. Construction was not a support function. It was a form of combat power. Seabees were integrated more deeply into operational planning. Their capabilities influenced target selection, landing sites, and campaign design. By 1945, this approach was fully institutionalized. Wherever American forces went, infrastructure followed immediately. The Seabees' presence became synonymous with permanence. Capture meant conversion. Every island became stronger after it fell. Yet the aftermath was not measured only in efficiency or output. It was measured in how each side understood the war's direction. Japanese commanders no longer asked whether an island could be defended indefinitely. They asked how long before it became an American base. That shift marked the collapse of the defensive strategy that had defined the early Pacific War. And as Japan faced mounting pressure from the air and sea, the deeper consequences of this transformation on morale, doctrine, and historical legacy became impossible to ignore. Those deeper consequences would define how the war was remembered, and how the role of builders came to be understood. As the war moved into its final year, the psychological imbalance between the two sides became unmistakable. For Japanese forces, the failure of island defenses was no longer a question of bravery or effort. It was structural. Soldiers and engineers fought with discipline and endurance, yet the outcome remained unchanged. Islands did not remain denied. They transformed into instruments of American power. This realization carried a heavy psychological weight. Japanese after-action reports increasingly reflected frustration rather than surprise. Repeated references appeared to the enemy's unlimited construction capability and rapid restoration of facilities. The language shifted from tactical critique to resignation. Defenses were described as temporarily effective, a phrase that quietly acknowledged their ultimate futility. Doctrine began to adapt, but too late. Japanese planners shifted emphasis from infrastructure denial to attrition. They attempted to maximize casualties rather than prevent use of terrain. Tunnel networks expanded. Static defenses were pushed underground. Yet this adaptation conceded a fundamental point. The surface of the island would be lost and rebuilt regardless. For American forces, the psychological effect moved in the opposite direction. The presence of Seabees created a sense of inevitability. Combat units advanced knowing that roads, airfields, and supply depots would follow. Even heavy losses did not disrupt momentum. Confidence replaced caution. The war felt directional rather than uncertain. This confidence shaped decision-making. American commanders grew more willing to attempt complex amphibious operations. Logistics were no longer the limiting factor. Construction speed allowed for aggressive timelines. The pace of advance accelerated not because resistance weakened, but because infrastructure kept up. In doctrinal terms, the war permanently altered how the United States viewed engineering in combat. Construction was no longer relegated to post-battle phases. It became integral to operational success. Future planning would assume infrastructure could and must be created under hostile conditions. The legacy extended beyond World War II. Seabee doctrine influenced Cold War base construction, expeditionary warfare, and disaster response. The principle that infrastructure could be deployed rapidly in unstable environments became a cornerstone of American military planning. Lessons learned on coral atolls informed air base construction across the globe. For Japan, the aftermath was more somber. The collapse of island defense strategy forced post-war reflection on rigidity versus adaptability. Engineers who survived the war later acknowledged the limits of static planning against an opponent capable of continuous reconstruction. Industrial depth, they concluded, had been underestimated as a decisive factor. The war demonstrated that fortifications alone could not compensate for industrial disparity. Skill and courage were not enough when time favored the builder. By 1945, the outcome was no longer in doubt. The Pacific had been transformed from a barrier into a network of American bases, each one reinforcing the next. The Seabees work had erased distance, neutralized denial strategies, and accelerated the war's conclusion, yet their contribution remained largely invisible in popular memory. There were no dramatic charges or iconic photographs, just runways stretching into the distance, ports crowded with ships, roads cutting through terrain once thought impassable. Quiet victories measured in permanence, and as the war ended, the full meaning of those victories would only emerge with time. When historians began to recognize that the Pacific was not conquered solely by firepower, but by the ability to build faster than an enemy could destroy, that understanding brings the story to its final reflection on what this conflict revealed about warfare itself. The Pacific War is often remembered for its ferocity, its naval battles, its island assaults, its immense human cost. Yet beneath the gunfire and headlines, another contest unfolded quietly, shaping every outcome that followed. It was a contest between permanence and adaptability. Japanese engineers built with precision, discipline, and resolve. Their defenses reflected a belief that well-prepared positions could hold against overwhelming force. Once completed, those fortifications were meant to endure. When they fell, there was little left to rebuild with. The United States approached war differently. It accepted destruction as temporary. It assumed loss could be replaced. It treated infrastructure not as something to protect at all costs, but as something that could be recreated again and again faster each time. The Seabees embodied that philosophy. They did not seek decisive moments or recognition. They arrived amid chaos and worked until order emerged. Their success was measured in function, not spectacle. A runway that worked, a port that unloaded, a road that connected. In doing so, they revealed a deeper truth about modern warfare. Wars are not won solely by defeating armies. They are won by sustaining momentum, by removing pauses, by ensuring that every gain becomes permanent before the enemy can respond. In the Pacific, the ability to build under fire proved as decisive as any weapon. The islands tell this story even now. Coral airstrips that once echoed with engines, roads carved where jungle once resisted, harbors shaped by necessity rather than geography. These remnants speak to a war fought not just with force, but with foresight. For Japan, the lesson was harsh. Courage and preparation could not overcome an opponent whose strength lay in renewal. For the United States, the war confirmed something enduring, that industrial depth, organization, and adaptability could reshape the battlefield itself. The Seabees did not win the war alone, but they changed how it could be fought. They turned destruction into opportunity. They transformed obstacles into assets. And in doing so, they helped bring an end to a conflict defined as much by what was built as by what was destroyed. In the Pacific, victory did not simply arrive. It was constructed.